Hello, welcome to Berkshire Guitar Amplifier Repairs. Stuart Smith with you as always in Reading, England. And on the bench it's a Laney Super Cub 12. Now the issue with this amp is that it blows mains fuses basically. And I have proven that it does that. I put a new fuse in, turn the power on, popped instantly. These are hybrid amps, in other words they are a mixture of surface mount integrated circuits, surface mount resistors and capacitors, and valves on a few discrete components. Yuck! Pretty horrible really, but anyway, there you go. They're made to a price, they're not an expensive amp. So I don't know whether I'm going to be able to fix this. I'm hoping it's something fairly straightforward. Let's get into it straight away. I'm just going to take the chassis out and start straight away on diagnosing the issue. Well, the first thing to do is a visual inspection, just to see if there are any obvious burnt or blown up components. It only takes a few moments and it's always worth doing. So an amp that's drawing a lot of current like this, one would suspect these HT caps maybe, one of them short circuit, but they look okay from this side, but you can't normally tell from this side of the cap. It's usually the other end that you can see leakage and stuff. And although this looks like leakage around here, it actually isn't. It's just some sort of glue they use to stick the cap down. So at the moment we don't know what the status of those caps is. This is a kind of hybrid board, so we have a mixture of surface mount chips and stuff like that, surface mount resistors and things. I really dislike this kind of construction, particularly the valve amps, but as you know, it's all down to price. Knocking it out for as cheap as they can really, and they don't care at all about repairing things. So I can't see anything here, so I'm going to power up the amp on my variac, which is over here, and I made this myself, so off on switch variac or bypass the variac, and a little volt and ammeter there, and also a lamp. This puts the lamp in series with the mains going in. And when you've got a short circuit on a piece of equipment or it's drawing a lot of current, there's not much mileage in just powering it up and blowing the fuse each time. So you can power it up, wind up this, and if that lamp glows, you know you've got a kind of short circuit condition on the board, so you don't need to just apply full voltage each time. So we'll do that and we'll see what's going on. Right, there we go, we're plugged in. And now we can wind up our variac. We're turned on. Now I can hear a hum from the amp and a sort of motorboating noise. Louder hum, starting to pull a bit of current, look, even at 120 volts. And there we go, look, see the bulb lighting? We're only at 150 volts and that bulb is pulling a fair bit of current. So basically we've got some issue with the amp where it's pulling too much current, so there's no point in going higher than that. Right, so what can we do without removing the board? Well, an obvious thing to do is to, and on this one it's easy, is to disconnect the secondary windings from the transformer. There we go. Obviously now that's now disconnected all the AC from the board. Now why would you do that? Well, sometimes you can get a shorted winding on the primary of the mains transformer. I've had that many times, and basically the mains transformers are no good. So if we turn up now and we find we still are drawing current, we have a faulty mains transformer. So let's do that and see if that's the situation. Wind up. We obviously won't hear any hum because the circuit's disconnected. It's not pulling any current at all at the moment, look. We're up to 110, 120, full voltage, absolutely nothing, no current being drawn, no bulb on. The primary of the mains transformer is okay. So we can put this back. Now what I'm going to do now is to take all the valves out and see if we still get this problem. I don't think it'll make any difference, and here's why. I wonder if you've worked it out for yourself yet. The problem is happening instantly we power it up. As soon as he turns on the mains, the fuse blows, or as soon as I wind up my variac, we pull too much current. Those valves haven't even had any time to warm up yet, so they're not doing anything. They're basically absolutely open circuit in their socket doing nothing. Of course, we could have a heater short or something on one of the valves, but that's extremely rare to get that. But anyway, I'm going to pull all the valves out, put that back and see if we still have our problem. And of course, that will eliminate a huge number of things if all the valves are out of the amp. Okay, there we are, all the valves pulled out. And we can now turn this up again. So here we go. I can hear the hum, of course. Turn up, motor boating. Bulb starts to glow. It's not a valve issue, which is exactly what I thought. Okay, so I'm going to do something else now. When you get an amp like this which is pulling current, you can set the variac to pull a reasonable amount of current, but not a stupid amount. And then you can check to see what gets hot. Now, it's not particularly easy to see what gets hot on an amp. In fact, I'm thinking of getting myself a thermal camera, which would obviously make my life very easy, but they are a bit expensive to get a decent thermal camera. But I don't really use it often enough to justify it. But anyway, I think I'm going to invest in that. And then, of course, what we would do, we would set this up to have a certain amount of current going through, just the bulb just about on, put the thermal camera on the board, and we would be able to see that this capacitor or this resistor or these diodes or whatever were getting hot. Without that, we're going to have to resort to some other techniques, and you might find them interesting, so I'll show them to you. Okay, I've turned it on, and what you're trying to do, of course, is feel where the heat is, because it's obviously dissipating a fair bit of power. Something is short circuit or giving a problem. I've just zoom out a little bit. So I've done some obvious suspects, like there's a voltage regulator on the heatsink here. I felt that's completely cold. The capacitors are completely cold. But I can feel some heat coming from around this area of the board. Now, your hand isn't very sensitive to heat, so I put my head in there and got my lip close to it. Funnily enough, your lip is fairly sensitive to heat. And I thought well, I can definitely feel some heat coming off the board, and I thought I felt it was coming from around this area here. So let me show you a little trick. Just basically get some alcohol and a cotton bud, and we're going to soak the cotton bud in the alcohol and wipe it over some of these components with the amp on. I'll put the amp on now. So I'm just setting, I won't show you with the camera, I've just set it so that the bulb is just about on, and I can both kind of feel and smell a warm smell coming. And I'm just going to put some alcohol around here. I want to see if zoom in a bit on that area of the board there. I want to see if the alcohol evaporates. It seems to be coming from around this power resistor. So that's cold, that resistor I can tell. The alcohol isn't evaporating or on any of these. It's not evaporating from these caps. What about these diodes? That's okay. Aha! This is interesting. This diode here has got a great big blob of alcohol on it, but watch what happens when I put it on this diode. Whoa, it's almost boiling off, look. Right, I'm going to turn that off. Just about feel that with my hand there. Right, so now what do those diodes do? That's an interesting question. I don't think they're the HT. Well, they're right next to the output transformer. So let's just, why don't we pull the output transformer, just to make sure we haven't got a short circuit on the output transformer. So let's I'm just going to turn on again. I'm winding up again now. Winding up, we've got 120 volts, so that's interesting. So I'm at full voltage now on the variac, and the fault has gone. So yeah, you can probably see that the alcohol is staying nicely on that diode. In fact, why don't we wind this up again and just plug this in and see if that alcohol boils off straight away. Oh, it did immediately, look. That's amazing. Right, so We got a bit lucky there actually. You can tart around for ages with this trying to find, which is why thermal camera, yeah, that would have been glowing really glowing like a bright spot on the thermal camera if we'd had one. And so this has kind of made me think I ought to just bite the bullet and get one. So, right, we know unplugging the primary of the output transformer cures the problem. Now, I think I said it might be a shorted turn, because that's not right, because all the output transformer does is take HT through one winding of the transformer and then back down to the anodes of the output valves. Well, one anode, and of course the other winding goes to the other anode. It's a very simple circuit actually. And with no valves in place, no current can flow through that output transformer. So whatever current is flowing through this output transformer, and we know it is because the fault happens when we plug this in, isn't going through the valves. It's something to do with these diodes. I'm wondering if they're sort of, I've seen them before, like snubber diodes or something they put. Let me go and pull the schematic for that, and we can have a look at what those two diodes are doing. But I think we've got a short circuit diode there. That would be nice if it was as straightforward as that. Okay, good news, I was able to get the schematic for this amplifier, this exact one. And here we are, we've got the output transformer here, and it takes the HT look and goes through that valve on one half the cycle, through that valve on the other half of the cycle. We've got these valves disconnected, so I was quite correct. There's nowhere for the HT to go. You know, it comes along here, goes nowhere, comes along here, goes nowhere. However, we do know it is going somewhere, and we know one of these two diodes is getting hot. So we have a short circuit diode is my guess. Now, these diodes, someone will doubtless tell me, I can never quite remember what they do. They're reverse biased, look, so with the HT here, there's no current going, this is ground, there's no current going through that diode. Current goes through a diode that direction, not that direction. So it can only be for some sort of flyback protection if the voltage becomes reversed due to the transformer. Then the current would go through this direction here. I'm not quite sure why they're needed though. Is it to protect the output transformer winding or something? I don't know. Someone will tell me in the comments. I think I probably did know at one point, but I've forgotten. So help me out here, you experts. You can tell me what they do, but that's basically what they do, something like that. They certainly don't conduct any current normally because they're reversed biased. And the fact that, say, this one here, which one actually is it? It's D6. It's this one here. The fact that this D6 is conducting current, so voltage is coming down here and through here to ground, shows that this diode is short circuit or something. Now we have a little bit of a problem. 1N5408, it's a 1 kV 3 amp from memory. Nothing fancy about it, apart from the fact it's 1 kV, which is a fairly hefty current. Sorry, fairly hefty voltage. By the way, in case you're interested, what that 1 kV is 1000 volts, of course. And what that means is you can put 1000 volts across it the wrong way round before it will blow. So let's just draw that out. So here's your diode, look. Normally they conduct this way, and it would have a 0.6 voltage drop across it. But obviously you can put voltage on here. Let's say you can ground this, and you can put voltage on here, and this won't conduct any current. But of course there comes a limit before this will break down. It's only a tiny little wafer of silicon, obviously, and when all's said and done, and if you put 10,000 volts on here, this would just completely blow up. So what voltage can you put on that? Well, that's the voltage that they specify the diode to be. You can get some pretty high flyback voltages under the right circumstances with inductors, so I guess that's why they've specified 1000 volts. Now the difficulty we've got is I don't have any surface mount diodes. I don't do anything at all on surface mount. By the way, if you're interested in surface mount, I've been watching an amazing channel on YouTube called Northridge Fix. It's an American guy. So Northridge Fix. And he does laptop repairs and stuff like that. The guy's an absolute wizard. If you want to see an expert working on surface mount stuff, which is 20 times more complicated than this, you've got to check this guy out. It's way above my pay grade to do the sort of work that he does, although of course with the right gear You can do anything. Anyway, so what we're going to have to do is find a couple of equivalent diodes to this. This is nothing special, I'll definitely have something. And then we're going to have to somehow, you know, make a bodge here, sorry, a temporary technical fix to put a couple of ordinary diodes in here. So I'll work out how to do that, but let's see if I've got any diodes first of all. Okay, I've got a couple of 3 kilovolt diodes here, which are even better obviously. So what we're going to do, we're going to remove both of those diodes actually. Yeah, let's change them both. The you probably can't tell, but there's a little marking there which tells you where the bar goes. Oh, that's not focusing very well, is it? So the bar is here and here with the 2 anodes joined together. Let's just check if that is correct. Yes, it is. Look, the anodes. That anode goes to ground. That anode goes to ground. So they are joined together. So we're going to try and make something like, I don't know really, sort of like this. Solder that into the centre and then bring these round like this sort of thing to solder them onto the ends. We're going to do something like that. But let's start by getting that both of those diodes out. Well, there you go. I hope you enjoyed that one. I certainly did. That's my idea of a perfect repair, where you logically diagnose what's wrong, you find out the component you think is faulty, you change it, and it all comes to life. No drama, no fuss, and we even managed to put some discrete components in where surface mount should rightfully be. Well, I'm not going to get involved in all that microelectronics, not with this hand. Look at this. Look, I can hardly even hold a soldering iron these days, boy. Hopeless. Anyway, hope you enjoyed it. I'll catch you on the next one. I suspect this video might be one that people will look at from time to time, because I bet you this problem happens on a lot of Laney cubs as well. Okay, bye-bye. I will see you on the next one.